Today we will discuss CR equations in polar form. For this, we have x is equal to r cos theta, y is equal to r sin theta. From these two relations, we find the derivative of x with respect to r as cos theta, derivative of y with respect to r sin theta. From these two equations, x square plus y square is r square and tan theta is equal to y upon x. That implies theta is equal to tan inverse y upon x. R means root x square plus y square. Then derivative of r with respect to x is 1 upon 2 root x square plus y square 2x. This becomes x divided by x square plus y square. X is equal to r cos theta and this term is equal to r. So we get curly r by curly x is equal to cos theta. Then curly r by curly y. Similarly, when we take the derivative of r with respect to y, we get y divided by x square plus y square and y is equal to r sin theta divided by r. So we get sin theta. Then from this relation, we find the derivative of theta with respect to x. This is equal to 1 upon 1 plus y square by x square. As derivative is with respect to x, then derivative of y upon x is minus y upon x square. This is equal to minus y divided by x square plus y square. Minus y is minus r sin theta divided by x square plus y square is equal to r square. So this is equal to minus sin theta divided by r. Then we find the derivative of theta with respect to y. As theta is tan inverse y upon x, so this is equal to 1 upon 1 plus y square by x square into 1 upon x. This is equal to x bound x square plus y square. X is equal to r cos theta. Substitute this value here. X square plus y square is r square. So we get cos theta divided by r. For the proof of CR equations, all these derivatives are required. So I am writing these values here. Curly r by curly x is cos theta. Curly r by curly y is sin theta. Curly theta by curly x is equal to minus sin theta by r. Curly theta by curly y is equal to cos theta divided by r. Now we find the CR equations in polar form. For this, we take a function, an analytic function, say w equal to u plus iota v. U and v are its real and imaginary parts. By CR equations in Cartesian form, we have ux is equal to vy, uy is equal to minus vx. So first of all, we will find the derivative of u with respect to x. This is equal to curly u by curly r, curly r by curly x plus curly u by curly theta by curly x. x. From our values, curly r by curly x is cos theta, curly u by curly r, curly theta by curly x is minus sin theta upon r, curly u by curly theta. Then take similarly curly u by curly y. This is equal to curly u by curly r, derivative of r with respect to y, derivative of u with respect to theta, derivative of theta with respect to y. Then substitute the value of curly r by curly y from here equal to sin theta, curly u by curly r, curly theta by curly y is cos theta by r, substitute here cos theta divided by r, curly u by curly theta. Then take derivative of v with respect to x, derivative of v with respect to r, derivative of r with respect to x, plus derivative of v with respect to theta, derivative of theta with respect to x, equal to again cos theta, curly v by curly r, curly theta by curly x is minus sin theta by r, curly v by curly theta. Then finally the derivative of v with respect to y. This is derivative of v with respect to r, derivative of r with respect to y, plus derivative of v with respect to theta, derivative of theta with respect to y. From here curly r by curly y is sin theta, curly v by curly r, derivative of theta with respect to y, cos theta divided by r, curly v by curly theta. Now substitute these derivatives in CR equations of Cartesian form, that is ux is equal to v by uy is equal to minus vx. Ux means this equation, cos theta curly u by curly r minus sin theta upon r curly u by curly theta is equal to vy. Vy means derivative of v with respect to y, that is sin theta derivative of v with respect to r plus cos theta divided by r, derivative of v with respect to theta. Suppose this is equation number 1. From second equation, uy is equal to minus vx. Uy means sin theta. Here we calculated this value as sin theta curly u by curly x plus cos theta divided by r curly u by curly theta is equal to minus vx. Minus vx means minus of derivative of v with respect to x is equal to minus cos theta curly v by curly r plus sin theta divided by r curly v by curly theta. Suppose this is equation number 2. Now multiply equation 1 by cos theta and second by sin theta and add these equations. When we multiply first equation by cos theta, left hand side becomes cos square theta curly u by curly r minus cos theta sin theta divided by r curly u by curly theta. Then left hand side of second equation is this plus sin square theta curly u by curly x plus sin theta cos theta divided by r curly u by curly theta equal to right hand side of first equation cos theta sin theta curly v by curly r plus cos square theta divided by r curly v by curly theta. Right hand side of second equation minus sin theta cos theta curly v by curly r plus sin square theta divided by r curly v by curly theta. Now this term cancel with this one. From these two terms take curly u by curly r common, then we are left with cos square theta plus sin square theta, which is 1. So we get curly u by curly r is equal to, in the right hand side this term cancel out with this one, and we are left with 1 upon r curly v by curly theta, as cos square theta plus sin square theta is 1. So this is first equation in polar form. To find second one, again take equation number 1 and equation number 2. Now multiply equation 1 by sin theta and equation 2 by cos theta, and then subtract these two equations. Now we multiply equation 1 by sin theta, equation 2 by cos theta, sin theta cos theta curly u by curly r minus sin square theta divided by r curly u by curly theta. Then left hand side of second equation minus cos theta sin theta curly u by curly r, this is r, minus cos square theta divided by r curly u by curly theta is equal to, right hand side of first equation, sin square theta curly v by curly r plus sin theta cos theta divided by r curly v by curly theta minus right hand side of this equation, so we get plus cos square theta curly v by curly r minus sin theta cos theta divided by r curly v by curly theta. In the left hand side this term cancel out with this one, take terms common from these two, minus 1 by r curly u by curly theta, then we left with sin square theta plus cos square theta, which is 1. In the right hand side this term cancel out with this one, again take curly v by curly r common, we left with sin square theta plus cos square theta, which is 1. This is second CR equation in polar form. These two relations are used for further calculations. For example, we have one article that in which we use these two relations. We have to prove that curly square u by curly r square plus 1 upon r curly u by curly r plus 1 upon r square curly square u by curly theta square is equal to 0. We have to prove that sum of these three terms is equal to 0. From first equation, curly u by curly r is equal to 1 upon r curly v by curly theta. Take derivative of this equation with respect to r. Curly square u by curly r square is equal to 1 upon r curly square v upon curly r curly theta. Then derivative of 1 upon r with respect to r is minus 1 upon r square curly v by curly theta. Now from second equation, curly v by curly r is equal to minus 1 upon r curly u by curly theta. Now take derivative of this term with respect to theta. Curly square v by curly theta curly r is equal to minus 1 by r curly square u by curly theta square. Then substitute this value here. So from this equation, curly square u by curly r square is equal to 1 upon r minus 1 by r square, minus 1 upon r only, curly square u by curly theta square minus 1 upon r square curly v by curly theta. Then curly square u upon curly r square is equal to minus 1 upon r square curly square u by curly theta square minus 1 upon r square curly v by curly theta. That implies curly square u by curly r square plus 1 upon r square curly square u by curly theta square plus 1 upon r square curly v by curly theta is equal to 0. To prove this relation, as 1 upon r curly v by curly theta is curly u by curly r, so this equation becomes curly square u by curly r square plus 1 upon r square curly square u by curly theta square plus 1 upon r into 1 upon r curly v by curly theta from this equation is curly u by curly r is equal to 0. So this relation is proved here by using polar form of CR equations. This was the topic related to the CR equations. In the next lecture, we will discuss some important theorems related to analytic functions. Thank you.